Our next one is Cryogenic Fluid Management Tool for Systems Analysis and Design. And the presenter is Matthew Moran.
What the goal and objectives that I set out with this was to create a public domain tool for performing system level first order calculations for common cryogenic fluid management topics. So the idea is no CUI, ITAR, classified data, just stuff that is in open literature, publicly available. And one of the challenges always with trying to come up with custom calculation tools like this is having documentation and understanding what exactly is happening with it. So I actually started with, in terms of objectives, the very first step being documenting the equations, the context, the the building blocks that would be used for these calculation tools, and then put it into a PDF format that's available online to anybody who wants to look at it. And this was actually shown here. The number one objective was the basis material that I used for the 3-hour short course I did this morning. So the second step or second objective is then to create an integrated Excel workbook that has calculation sheets that will do all of the calculations that are in this. By the way, this is just passive CFM. The next report in the series that I have planned will be active systems, so cryo-refrigeration and mixing and that sort of thing. But the second part then of the objective was to create these calculation sheets that could be navigated easily. And I'll show in a minute a couple of embodiments of that I've been working on in beta mode, and hope to have something to share with the community to get some folks to look at and try it out and see where the bugs are, where things are working, where they aren't. Two versions of that: an online version. There's a way to put an Excel worksheet, an instance of it using the web version onto a website, so that you can actually have an interactive. And I'll talk a little bit more about that interactive spreadsheet, and then also a desktop spreadsheet that allows you to use Visual Basic and property calls, which I'll also show what I'm using for that. The third objective is to create built-in user-defined functions within Excel and Visual Basic, so that this calculation tool then can be made an add-in, for example, so that all of these functions are then available automatically in any new spreadsheets that someone's creating, so that they can begin to do more complicated systems kind of calculations and build these functions into their system model as needed and again, these are first order. They're mostly closed form solutions, although doing it in programming in Visual Basic does allow some amount of numerical analysis or time stepping algorithms. So that's a possible future addition. The fourth objective then is the other platform that I'm finding is and using myself, and I think has a lot of forward, I guess I would say, potential, is Python. So creating functions in Python, essentially these are all tied together. Everything is documented in the report. The calculation sheets do it by spreadsheet. The Visual Basic does it by functions, and Python will be the same way. It is already have some functions in there. And the idea is they can be then used in Jupyter notebooks, and I've got a quick example of that if you haven't had an opportunity to use that, as well as many other platforms that Python supports, which, there's a variety of things. Of course, as a programming language, it does, but one of the areas where it's getting a lot of usage is in scientific and engineering type endeavors. So there's a large community of users and a lot of modules and shared libraries that you can use for it. And speaking at the last objective then is the building of a library that could be imported into any Python environment that would have all of these built-in functions. And I'm just, this is obviously doesn't exist yet, but it would be a simple call for those that are familiar with Python of import cryo-FM, and then all of those functions would be available just like other modules that are built into Python. So this is a screenshot of what's currently up that I'm working in beta mode with for the online version. And I've set it up so that they're side by side. This is actually the help screen for the Excel instance within the website that kind of shows, the user inputs in yellow and property values in blue and then results in green. There's also a verification case for each of these calculation sheets so that you can go back and make sure that the calculations are correct. On the user defined function side of things, it also is helpful as a unit test. So this is the help screen of that. On the right-hand side, then side by side, this is at least the way have it set up now. And again, one of the things I'd like to get feedback on as I start to roll out a beta version for people to take a look at. But this is the full PDF of that report. So you can actually, I think it shows it's 150 pages. So you can scroll down here if you're doing a calculation, and it might be better to show the next screenshot. You can scroll down in the report. This is the same online version, just now showing the table of contents on the right-hand side of the document. And on the left-hand side, these are the calculation sheets that have been finished. And you can see there's a pretty close to a one-to-one correspondence on top in terms of topics, so that you can go to a particular topic and understand how the equations are used, what are the insights and how to use them and where they're applicable and where they're not, that sort of thing. And I also include, this is actually the homepage on the online version of this, define constants and then unit conversions. Everything's in SI units in the actual code, but if you're working in customary units, you can always do some quick calculations here on the home sheet. And then I think I have a very simple example of the online. So this is the calculation sheet for bond number, Reynolds number, and then, I think that's all that's on this one. So again, the navigation, you would hit this home screen to go back to the previous one I showed that had all of the calculation sheets. The reference report is actually just this. It opens it up in a new window. And then NIST fluid properties goes to the NIST thermophysical properties that you can get online calculations for. One of the downfalls I haven't figured out a way around just yet with the online instance of Excel is I can't access CoolProp, which is an open source properties evaluation code or software that I use on the desktop version, and it works great. But I have to still figure out if there's a way to get it to work in this online instance. So what I've done as a workaround for now is these are drop-down menus. So oxygen is shown. There's about a dozen or so fluids in there right now in this worksheet. And then this drop-down menu either says use CoolProp if you're in the desktop mode and you have the CoolProp DLL or add-in in Excel. But if you're online, you can do the drop-down and say use values below, and you can take, for instance, go to the NIST fluid properties website, find out what are the fluid properties for this set of conditions. And that's one of the reasons I have this in red. It's very easy to forget that if you change any of these conditions, of course, pressure, well, at least pressure anyway. And this is, you're going to have to change these numbers. And what it does is if you have this drop down to use the values below, it automatically pulls these in over here. This is a little bit, for those who have run into this, even with RefProp, when you get a spreadsheet that has property calls for something you don't have access to, you end up with a screen full of, value errors or whatever in Excel. So this is an attempt at work around that, at least for the online version. So then it calculates bond number. This then correlates equation number to the reference report, and you can look up, side by side, what is the equation that's being used, what are the variables, and then a little bit of discussion. This is one of the simpler topics showing the variation in an example cylindrical tank, the shape of the fluid liquid gas interface based on bond number. The higher the bond number, the more flat the interface, the lower, the more curvature that you get in that interface. And the same with Reynolds number. To look at Reynolds number, you'd scroll down a little bit more and look at the equation 1.2 to get that information. So that's sort of the sense of the online version. The desktop version has the advantage of being able to use property calls directly. I have chosen not to use RefProp, even though it's a gold standard. CoolProp, by the way, has been validated against RefProp for the functions that it and properties that it evaluates. But the nice thing about CoolProp is that since it's open source, anyone can get it and use it, so it's easy enough to install on whatever machine's being used. And in addition, there's no the license doesn't, there isn't any. It's an open license, basically open source license, so you can have it included in any code that you distribute. So it kind of gets around any issues with distributing something that has a license constraint or restriction on it. So this is just an example. These are specific state points that are used in the other calculation sheets. That I happen to have one sheet that does the property calculation with CoolProp in the desktop mode, and then saturation conditions. And you can go through here and change the fluids, the pressure, temperature for the specific state points, and then just the pressure, and it'll find the saturation temperature and the other properties there. One of the advantages in Excel too, one of the built-in things is you can use the goal seek in there to reverse, basically put in, so let's say you want to find a saturation temperature that's different than that. You can use goal seek to find out what the associated saturation pressure is. And then again, this is the verification case for this particular sheet. So just examples. The other objective I mentioned, the user-defined functions, I just put these in here to show how simple and easy these are to put together, but the idea is to build this up. These are the function calls you use in Visual Basic within Excel. Most people are familiar with, to some extent, with the macros, which are using Visual Basic, but you can create user-defined functions if you haven't done that. Directly in there, then they become visible and usable just like the other functions in Excel. So you can hit the F of X button in your, in the input and get all kinds of information about what the inputs are to the function, and bring it back the return value, like the mass of a gas or fill fraction or Reynolds number, back into any cell in a worksheet. So it gives you a lot of flexibility. This is the same sort of thing, only now in Python. So in Python, in this case, I'm sorry, on the Excel side, let me just point out, to use the CoolProp properties, it's got to be an add-in installed. Again, it's freely available, open source. In Python, they have a module available that you can import, just like the other Python modules, if you're familiar with using Python. And then once you import it, it's available for any of the calculations you're doing. And in this case, Python, this is how you define a user-defined function, and it operates in a similar way. You pass in the variables, input variables, and it returns an output. So trying to come up with ways to make this the most usable. There's probably other ways or other codes that could be written in, but bandwidth and time and effort has to be taken into consideration. This is a Jupyter Notebook for folks that haven't used it. Some folks are actually starting to use this in some cases as a replacement for Excel. It doesn't totally replace it in my mind, but it also has some features that I would call similar to a program like MathCAD, where you can kind of linearly describe what you're doing and then run the calculations, and it's interactive. So they have markdown cells, it's called, where you could put titles like this and more extensive comments if you choose. Again, it's importing the CoolProp to be able to evaluate properties. Oops, sorry. And then you just define your inputs here. Again, I think this works nicely for, in the end, sorry, this is a Reynolds number calculation, so it comes up with a Reynolds number formatted in scientific notation. So I think this kind of an approach with Jupyter Notebook, I think, works nicely. And if you're trying to lay out the logic for a particular algorithm you're putting together, and it's actually used a lot for in the artificial intelligence community and machine learning to do that sort of thing. And there's a lot of capability in Python. If you're not familiar with it, it's worth a little bit of time to look at. And of course, you can Jupyter Notebook is just one of the platforms you can use Python on. There's many others. So just kind of wrapping up here, where things are at and kind of forward plans. This passive CFM report, as I mentioned, is done. At least first few versions of it have been completed and are available online. So the next one would be an active CFM report that will cover cryorefrigeration and other active cryogenic fluid management type of operations and systems and technologies. The next one, I think after that, third one, at least on the radar screen, I'm thinking is a systems modeling one to start to talk about how you would take a tool like this and begin to put a system model together. The status of the Excel Deskbook, it's desktop and online versions are under active development. I'm hoping to get some beta testing and inputs from the community sometime soon. I put an email link in here for, if you're looking at the proceedings later and you're interested in this, please shoot me an email and I'll save everybody's email that's interested and try to get them access to the online version to see how that works out. The VBA and the Python functions, custom user-defined functions, are also under development currently. Again, I think on the Excel side, probably an add-in is going to be the best way to implement that, so that you can easily, pull it in and import it as an add-in to Excel, and then you've got it accessible in any spreadsheet you're using. And then, as I mentioned, the Jupyter Notebook examples are planned, and eventually importable Python library. I've not started on that, and have started on the function calls, and of course a little bit of Jupyter Notebook examples, but a long ways to go there. But that's kind of the status and where it's at. And then I'll just wrap up again in the proceedings. You can click on these. These are all linked. This is that report I mentioned. That's the reference report that the calculations are based on. It's available online. This is a post I did a while back on different tools for engineering analysis and modeling for custom tools. This isn't commercial. So you're welcome to take a look at that. It has a lot of information about Excel and Visual Basic, and course notes from a course I taught for about 10 years to different companies and ATI and a few other I think extension schools for professionals. And then some other things that might be of interest: hydrogen systems development, kind of a history, present, and future stuff for folks that are working in hydrogen. There's a lot of interest in the private sector on this for those that are curious about energy storage or even some of the aircraft work now that's going on liquid hydrogen. That's where some of my customers, the industries are involved in. And then an adaptive systems approach that I use on a lot of projects that other people have said they find valuable when I've shown it to them. So I put that up on the website so you can take a look at it. And then finally, some information on densified liquid hydrogen and no loss or zero boil off systems, which will be part of that next active CFM report that I'm pulling together. But in the meantime, this gives some information on some of the work that's been going on, some of the systems that are in place, including the SCARD system that I did for the new liquid hydrogen Dewar 1.25 million gallon usable liquid hydrogen out at the Launch Complex 39B. And that is the end of my presentation. Thanks for your time.
Handle the maintenance challenge of developing across multiple platforms and languages such as Python, VBA, etc.?
That's an excellent question. One of the approaches I try to take with this is an incremental approach, and I think that's, of course, as this gets larger, that becomes a bigger issue. It's one of the reasons that I've built in verification cases right from the start, so that it's easy to make sure that any changes haven't corrupted the calculations. But I hear what you're saying, and I totally agree. It's an important consideration, and quite frankly, in my mind, always one of the drawbacks of any custom codes is that they don't have the same level of resources and efforts put to them as commercial codes. So I'm trying to be careful not to just add more noise to that. I guess set of software, and try to put something in place that is incrementally as locked down and verifiable as possible.
Okay, I would just like to second your motion on the usefulness of functions and subroutines in Excel for writing macros. In my opinion, they're one of the best features of Excel.
Yes,
I've, it's often easier to understand um, a procedure or a function where everything is written out in stepwise form than a cell with lots of nested functions inside of nested functions inside of nested
absolutely,
functions.
absolutely.
Yeah. We have another question here. Any plans for MATLAB?
I think that would be third on my list, Tony, and I I've really struggled with that. I don't use MATLAB a lot. I think that would be probably a natural next step to consider. Um, it's in the back of my mind. I'll put it that way. Again, it gets back down to bandwidth, and as Christopher asked in the previous question, it adds to that problem then too of how do you maintain keep maintenance across multiple platforms. But maybe there's a way to collaborate with the community on this, and perhaps once some of these are available in either VBA or Python, folks that are familiar with those languages could maybe do some kind of translation to other platforms of interest like MATLAB. Are there existing Python libraries you think are useful to further this development or as connected tools? Yes, quite a few, and I'm still in the learning process with that, to be quite honest with you. But it's the number of Python libraries is almost mind-boggling. What I tend to do is when I'm trying to do something, I'll just do a quick search online, and invariably there'll be 2 or 3 or 4 different options to look at. But there's a lot of plotting capabilities. There's a lot of analysis capabilities that are in the Python libraries. As I mentioned, CoolProp is available as a library, so it's easy to pull that in and be able to do thermophysical properties, which is extremely helpful and important with cryo stuff, of course. So um, that's probably the extent of my beginning knowledge of Python libraries. But I have found a few books that have been helpful on those lines, and you could probably Google them and find the same ones. But one of the recent ones I've read was Python for Excel. I just looked back at my bookshelf and remember the name of it. It's been put out, I think, a year or so ago, and he does a fantastic job. It's the author of Excel Wings, which is one of the open source ways of pulling in Python macros and user-defined functions into Excel. It works okay. It's a little bit slow, to be honest. So I think that's why I tried to see if I could just go with Python and use it with Excel too. But there's also lots of other good information in there, both for Python and as well as controlling Excel from Python, even if you don't have an Excel license. You're essentially you can push out Excel formatted tables and plots and everything else from within Python. So a very powerful tool, more powerful than I've learned how to totally use, to be honest. I see the IT security point. That's an excellent question, Tony. Actually, both in the case of CoolProp and of course Python, I think that's I use this on my business laptop, so it's my risk that I'm taking with my own equipment as far as using open source, but software and platforms. But yeah, I would strongly encourage anybody that's seriously looking at this to talk with whatever organization they're in the IT department and see what their attitude is in terms of this. I would be surprised if there is an organization that has somebody using Python, but they may have constraints on who they consider to be an appropriate user of an open source software development platform. I'm not sure. And I have not checked to see what the attitude is, I guess, is of NASA in general.